Study Unit 1, Lecture 7. This lecture and the subsequent lecture will briefly discuss a family of devices known as thyristors. A thyristor is a generic term for a family of devices which consist of multiple p-n junctions. The basic silicon-controlled rectifier shown here is a thyristor which has 4 doping regions and 3 junctions. A general property of thyristors is that they have a latched on state and a stable off state. For the silicon-controlled rectifier or SU shown, the behavior of the device is determined by the doping profiles as well as the width of the various doping regions in the device. Characteristic of thyristors, there is an anode, a cathode, and a gate. In this example of the SCR, the enter region has a very low doping concentration and is wider than the other regions. This low concentration and width mean that the space charge layers need to penetrate and can penetrate deeply into this region. This allows the junctions J1 and J2 to a very high reverse blocking capability. For the simple representation shown here, by applying a voltage or current to the gate, it will turn this part of the device on, allowing current to flow from the anode to the cathode. The SCR can also be considered as two bipolar devices interconnected with each other. A standard SCR construction is shown here in Figure A, but can be redrawn as shown in Figure B to appear as two independent, or rather two interacting, PNP transistors. Finally, in Part C of the diagram, the SCR is drawn as two bipolar transistors. Transistor T1 is an NPN, and transistor T2 is a PNP transistor. The application of a positive voltage across the anode and cathode is not enough to cause conduction through the device, because the PN junction at the gate of the device is reverse biased and must first be forward biased before conduction can happen. In other words, both the junction here must be forward biased, this junction must be forward biased, and this junction must be reverse biased before conduction will happen. The collector current of transistor T1 provides the base current for transistor T2. Additionally, the collector current of P2 provides the base current for T1. This configuration means that there is a feedback mechanism between the two transistors, and if the loop gain of the feedback network exceeds 1, then there is a regenerative effect and current will flow from the anode through to the cathode. The base current of the PNP transistor T2 with a DC current gain of alpha 2 is simply IB2 is equal to 1 minus alpha 2 multiplied by the current at the anode minus ICO2, where ICO2 is the collector junction reverse bias leakage current. The collector current of T1 is given by I collector current 1 is equal to alpha 1 multiplied by the cathode current plus ICO1, once again where ICO is the collector junction reverse bias leakage current. Since the base of transistor 2 flows into the collector of transistor 1, these two current equations can be equated. By Kirchhoff's current laws, the cathode current must be equal to the anode current plus the gate current. The anode current can now be expressed in terms of the gate current as well as the alpha of the two transistors. Refactoring allows the anode current to be written in terms of alpha 1 multiplied by the gate current, the two collector junction reverse bias currents, and the loop gain of the feedback loop formed by the two devices. By inspection, it can be seen that as the loop gain approaches unity, the denominator of this equation for the anode current becomes very small, which means this results in an increased current through the device. What is effectively happening here is that the two transistors drive each other into saturation, allowing more and more current to flow through the device. To turn the device on, current is injected into the gate. Initially, the alphas of each transistor are quite small but rapidly increase. Eventually, the device turns on completely and the injected current from the gate is no longer required. There is more than one way to latch the SCR into the on position, then injecting current in at the gate. If the voltage across the anode and cathode is large enough, then this will cause avalanche breakdown at the central junctions, which is enough to start the regenerative process and essentially drive the alpha values up and driving the loop gain towards 1 and thus turning the device on. The device can also be turned on by inducing a ramp at the input where the maximum value of the ramp is less than the forward bias voltage of the junction. This behavior will effectively induce current flow across junction J2, which in turn encourages the regenerative effect, which increases both alpha 1 and alpha 2 and turns the device on. The final mechanism is if the temperature is enough such that the leakage current which exists at junction J2 is enough to inject enough carriers to cause the alpha 1 and alpha 2 to increase such an effect that the loop gain approaches 1 and this starts the regenerative effect and the device once again turns on. There are of course other different types of SCR, such as the asynchronous silicon controlled rectifier. The primary characteristic of the ACR is that the ACR does not have any usable or repetitive reverse blocking ability, hence the name asymmetrical. By sacrificing this reverse blocking, there are significant improvements in lower on-state voltage, it has a higher forward blocking voltage, and it has a faster turn-off characteristic than the classic silicon controlled rectifier. The reverse conducting thyristor is electrically similar or equivalent to a silicon controlled rectifier, with the exception that it now is in anti-parallel with the diode. The purpose of this diode is to reduce any interconnecting lead inductance which may be present in a normal silicon controlled rectifier. Finally, examples of other thyristors are a bidirectional conducting thyristor, a gate turn-off thyristor, a gate commutated thyristor, and finally a light triggered thyristor. These devices all have the same fundamental function as a silicon controlled rectifier, but have architectural structural changes to suit some other application.